Hello guys, this is a 2007 PT Cruiser that has a Evap code. It's in memory. We don't have an active code, but we had a couple of codes in the memory. It has a P0441 Evap Purge System Performance, P0440 General Evap System Failure, and then we have a P0452 Natural Vacuum Leak Detection Pressure Switch Stuck Closed. So this P0452 is basically that's the input the computer uses for leak detection. So at the bottom, right next to the fuel tank, we have an NVLD assembly, and I'll show you here in the diagram how that looks. And I made a video, a little bit longer video. I'm going to leave a link in the description how this system works and how to test it, how I test it anyway. So this is the power control module. We have a purge solenoid here, and so NVLD assembly. It's on the atmospheric side of the charcoal canister, and basically has the solenoid and the switch. So now on the solenoid is used, this is a vent solenoid, and the crosset is used to actually vent the system, not to close, then like a GM. Now this switch is basically input. Inside this assembly is a diaphragm, and this diaphragm is going to pop open at 1 inch of water, of vacuum. It's going to pop. It's going to pop to close the switch. Okay. So again, I had this explanation, I think, better in another video. So basically, what it is, it's a pull-down design. Switch, computer sends 10 volts with a key on, engine off or engine running, and 5 volts with a engine off all the time, and monitors this voltage. When fuel cools down, it's going to create the vacuum, and this switch is going to close, and the computer is going to use that as an input to figure out if we have a leak or not. And this solenoid, again, it's used to vent during the purge. It's pretty much activated all the time. But we have a 3-wire connector at this NVLD assembly. We have a white and dark green. That's the solenoid. The black is ground, and orange and yellow is a switch. So this solenoid and switch, they share the same ground. So to find this problem, the switch is the most common problem, but what I have here is so the trouble is we don't have this system does not use a tank fuel tank pressure sensor, so we don't really know what's the pressure inside the system, other than just if the switch open or closed. But the switch is supposed to close at 1 inch of water, of vacuum. So what I have here is a 5-volt regulator. I'm using a GM pressure sensor, and I have the Chrysler fuel tank cap that I made this adapter here, and this is the one that comes up with the car. So right now I actually have this little pump that's just using it to pump the vacuum with. So right now I pull the vacuum up, and now I'm sealed, and so this has to be done a couple of times to catch this switch when it's acting up. So right now on my blue channel is my switch, and right now this was when the car was off, so you can see it's here's a 5 volts. So 5 volts is open, 0 volts is closed, and here's my pressure, and the reads around middle of it, 1.6 inches of water. I did customize my picoscope for this sensor. Again, in my other video I actually explained how I did that. So what happened here, I had to pump and release the pressure, pump and release the vacuum a couple of times to get this to act up, and I finally did it. As we can see, my vacuum is pretty steady, and at this point switch actually was open, and it should not. It should stay closed this whole time. And right here it was okay. Here's the vacuum was released and the switch was open. I pulled the vacuum down again, and finally it necked up on me, and so this is what happened. So this is confirmed problem with the switch. Now, if you would have a switch closed or open all the time, we of course have to address our wiring. But right now the wiring is fine. I'm getting the 5 volts at the switch with the key off, and I'm getting 10 volts with the key on. So I'm gonna run this again. I'm gonna start up again, and we can see the switch now. It's still closed, and my vacuum is still holding up actually pretty good. So right now I'm gonna release the pressure. I'm sorry, release the vacuum, and we can see the vacuum is going back up, and at some point this switch is gonna open. So this is an intermittent problem. We just have to do this 4 or 5 times until we finally catch this. And then actually it was kind of funny because last week I had a code P0453 switch stuck open. So this thing is acting up for sure. So right now it will probably work okay, but again it has to be done a couple of times. I'm gonna just release the vacuum, and we'll see now the voltage is gonna go up to 10 volts now. It's gonna now went back to 10 volts. And I'm gonna get you guys on tripod. So that's what this is how I do this test, and with this we can actually I can once I pop my once I pump my vacuum, I can actually look for leaks, and if the vacuum goes down too fast, then I have some kind of leak in a system. So let me just get this tripod and I'll. So and this vacuum slowly is releasing, and at some point this switch it will open. But now again it's very intermittent, and it's hard to catch this when unless you just do it a couple of times. Okay, so now I'm gonna release the pressure. It's slowly releasing itself. So switch is actually it's released now. Switch is open. So let's go ahead and pump the vacuum. So what I'm gonna do, I'm using this this pump just very slowly. I mean, that's just a little bit of and this is actually almost empty tank, and you can see it's already pulling the vacuum, just a little bit of so right now actually it's a -1. Let's see, at this point actually switch should close. Here we go. This is another problem. Now it's stuck open. I have enough vacuum for switch to close, and now it did. Okay, it should close earlier because it should close at 1 inch of vacuum. But it's all over the place, this signal is. Look at that. I'm gonna put some more vacuum. So this is definitely oh, look at that. Yeah, there you go. Okay, now this is kind of strange because it went down to this still key on. We should have let me see this. Oh, I got my system sealed. You can see it holding the pressure really good. So this is a good test. So again, this is what I did. I'm just gonna seal this with my clamp. So now I know I don't have any leak in the system, and my purge valve is holding pretty good as well. So so let's just stop this real quick and go back for a second and see. This is kind of weird here. Oh, come on. This is definitely a problem. This should go to now it's actually it went from 8 volts to 3 volts. Look at that. It's at 3 volts right now, so they should go down to 0 as I'm pulling the vacuum down. It's just kind of maybe it's gradually going down because I did not have enough vacuum, but it's kind of weird. I went to 3 volts and then finally went down to 0 volts. This in a way could be a problem with the ground. If the switch doesn't have a good ground, you know, it cannot ground the signal, but it does. So that's a so now we are at like a 800 millivolts. It should be less than that. So I need to check the ground and make sure the ground is okay, and if that's fine, you know, I need to replace this NVLD unit. Just release the pressure again, vacuum again, so it should open now pretty quickly. There you go. It is kind of weird. It goes to like holds at this point, it holds at 3 volts or so, and then okay, let's pull the vacuum again. Now it went down. Release the vacuum. Opens up. Now it's working okay. Open up. Again, it's intermittent problem, so it's kind of weird. I've never seen this before. That kind of gradually would go. I think it actually has a resistance in a sensor. Now it's at 3 volts. Now it's completely closed. Okay, well, I mean, for me, this is good enough. I mean, again, I got this at the time when the switch got open, and so okay. That's actually a pretty good pump. I mean, this tank is almost empty, and I just squeeze once, and I make enough vacuum instead of using the vacuum pump. I mean, this is a lot faster. Open it again. It is just acting up, and this is kind of weird. I mean, this is a weird as well, because you know, this is vacuum is dissipated, you know, but now this is kind of weird as well. It went up to like 7 something volts, and then went down again, and then went up. It's definitely, this switch is acting up. There's no reason for this to do. This should just go up. Okay, well, I'm just going to replace this unit. I have enough evidence that this switch is not working where it should. And I think what's happening here is just because this vacuum is jumping when I'm pressing the pump, you know, it's kind of, now you can see it's nice and crisp this time. Okay, well there you go. Okay, let's open up my fuel cap, and I release the vacuum faster, so that's okay. But again, I did find the moment when it was acting up for sure. The switch was open, and my vacuum was steady, so it should not do that. So okay, well I'm gonna replace this unit, and actually I'll show you guys what it looks like. I think this is just when the vacuum gets to the point where it's going to switch open, and this is what kind of happens. I think that's normal. Yeah. So this is the unit. It's right underneath the car, and this is a 3-pin connector. One is the solenoid, one is the ground, and one is a switch. So, oh, look at that. There you go. This is what's happening. Look at that now, guys. There you go. That's another glitch right there. There you go. Sweet. That's nice. This is right there is another glitch that was dropping down, and they should not, because you know we did not have a vacuum anymore. So we just have to do this until we. So this is it. This is nice. We can see that vacuum was, you know, right at this point the switch open, and then like you can see the vacuum is dissipating, and at some point the switch closed down again. It should not. It actually didn't close all the way. It went down to some like 3 volts. It shouldn't be doing. It should not do that. So and this is normal operation. This is where it should work. But at some point it was stuck open, and then it was kind of going down to kind of stuck closed. Okay. Again, as I said, I got enough evidence. I'm okay. Just replacing this unit. It should be fine. Okay. All right. Sorry. Alright guys, so that's the unit right there. This is a electrical connector, just pretty much just one bolt. You're gonna have 2 hoses. You're gonna unhook those. This is a charcoal canister here. So I did check my ground is okay, so I don't have issues there. So I'm gonna replace this unit, and this should be fine. Alright. Okay guys, we got this piece out. Something else you want to make sure that you don't have any dust inside of it. This one looks clean. Little tip, it's pretty tough to pull these hoses off of it. What I end up doing I dropped a strap on the fuel tank on the passenger side, so I kind of angled the tank a little bit to give you a little bit more clearance. So it took me maybe 15-20 minutes to get it done. It would be a lot faster if I would drop the tank. Just one end, don't touch the other strap. Just drop one strap on the passenger side, and it kind of pull the tank down a little bit, and it will be okay. Alright, so here's the key on. Got 10 volts, so that's a 0 pressure right now. So let's pump it up a little bit, and let's see. We need to hook it up here. Okay, let's see what happens. Look at how nice and clean the signal is now. But no more those steps that was happening last time. So I'm going to release the pressure. Boom, goes right back up. Sweet. That's a fix for sure. Get this back on. Okay. Just do a couple more times to make sure it's. There you go. Nice, clean. Switch down, go back up. I'm happy with this. It didn't close this time. Maybe it was, there you go. I don't think I had enough actually. I didn't have enough vacuum here. It was right, needs to be kind of right there to close. I didn't have enough vacuum, but that's okay. Okay, release the vacuum. Do it again. One more time. Nice. Okay. Alright, I think this is fixed. Got it released. Okay. I did actually, this time I opened out my tank, but it's already on a 0, so on the threshold here, so it got open, so. Those are good, open. Okay, alright, this is it. This is fixed. I'm happy with this. It should be okay. Alright guys, so this is what this is my setup. I have the pressure sensor from the GM pressure sensor, fuel tank pressure sensor. Got this cap from AutoZone for like $11. And this is what it looks like. You just drilled a hole through that, put a little hose, put some JB weld at the bottom so it doesn't move, and give you a good seal. Here I get the little adapter, so I can have a pressure sensor on one side and a pump on another. Pump the pressure, and you should see the switch closed. Hello guys. Car is gone, but I decided to take this unit apart to see exactly, to get a better understanding how it works. So before I get to this, when I diagnosed this car, I did not check my purge valve. I should probably pull the vacuum and activate the purge valve just to do it a couple of times and make sure that my purge valve is not sticking. But seeing a wrong input on my switch, I didn't think it's needed, but I should have done that. And also I never addressed my fuel tank cap from the car itself. I did visual inspection. The gasket was okay, and the filler neck didn't have any rust on it, so I kind of missed that as well. So what I probably should do, I should get my little unit and put it out under the hood where the test port is, just to disconnect my fuel tank cap, and take the port cap out and connect my pressure sensor in it, draw the vacuum, and just to kind of look if it's going to hold the vacuum with the fuel tank cap on from the car, so kind of test the fuel tank cap as well. So, but I just kind of missed both of those. I didn't think it was needed, because when I saw that signal, and it was kind of fooled me a little bit as well. But the bottom line is, when we see the signal on the supposed to, from the NVLD unit, when the vacuum reaches the threshold, that switch should open and close immediately from 0 to 10 or from 0 to 5 volts. There should not be any at some point we could see it was going at 3 volts as the vacuum was, the depleting. So it should be just a clean on and off signal. This should, you know, so that's I kind of missed. Again, I did not test the purge solenoid, and I did not check. I mean, I did not test my my cap, my fuel tank cap, but. It is what it is. I mean, this was a problem anyway. So here's the unit, and this is the part that kind of sits on the top of it. This is where the electrical connector is. So when you look at this way, one on the left side, on the right side is a ground, and the far left is solenoid, and the one in the middle is a signal. It's a switch. So on this side here, this is the filter side, and this is the charcoal canister side. So anyway, this is the diaphragm. This is the part that does pretty much all of the work, and we can actually remove that as well. So this is the diaphragm that controls the pressure in the system, and it releases the pressure and the vacuum when that reaches the threshold. Okay, so this is diaphragm. It sits right in here. Okay, so now in the middle of it we have a seal, and that's what actually, you see, goes in and out. That's what physically will release the pressure or vacuum from the system, and it's going to draw the fresh air into the charcoal canister. So now, so this is diaphragm kind of sits here, and then we have this cap kind of sits. I'm just going to pull this out. So we got these two connectors from the switch, and right there, that's my switch, and so that kind of goes all together like that. So again, when pressure goes up to half inch of water, this diaphragm is going to pull down, and it's going to open this seal underneath, and also when a vacuum happens, it's going to do the same thing. It's going to open this seal underneath, and it will the maximum vacuum is up to between 3 to 6 inches of water of vacuum. The system's going to get open. Now the right underneath is a vent solenoid. So both this diaphragm and the vent solenoid is going to open this seal. So this is what seals the system. Okay, so right there. So now these two wires, I'm just going to activate the solenoid, and we'll see this is going to open. Now the vent solenoid is, as I said, it's open all the time. As soon as I start the car is going to energize the solenoid. Is going to open this valve. Okay, so we're going to have fresh air draw into the system. Now this will be sealed when the computer is doing a large leak test, so it's going to seal the system. This vent is going to stay closed, and we're going to start drawing the vacuum in a system, and then this switch should close, and that time frame that this program in the computer is going to figure out if it has a large leak or not, when how long it takes for the switch to close. So I'm just going to activate the solenoid. And also the solenoid is used for the engine to calculate the flow of the Evap. So see that? And this is the pulse width modulated signal. So this it's like a, I can't remember, like a 50% duty cycled. Okay, so that's that. So now we know this is the fresh side, this is the vacuum side. Okay, this is the Evap side, this is the filter side. So now that's how that works, and this diaphragm is going to control this vacuum and the pressure when the car is off. This diaphragm, as the engine cools down, it's going to create the vacuum, so it's going to open the seal, and also when pressure increases, when it's hot outside, the pressure inside the tank is going to increase, and this diaphragm is going to open up the vent. And also during the refueling, it's going to do the same thing. It has to be something that can that can draw the fresh air as we fuel the tank. So so now here's the how the actually switch works, because every time this diaphragm moves, it's gonna open this seal here. So how we basically seal the system for the computer to do the to see the input from this switch. Now there's basically two chambers in this unit. There's one chamber here, and there's another chamber actually above the diaphragm. And right where the electrical connector is, there's a passageway right in here where the air actually go through. And I'm going to blow this so you guys can see that. So right in here, I can hold my finger. I can feel the air escaping. So now when we have a diaphragm, and a diaphragm is going to be connected here, and that's the switch. So kind of basically see this part of the diaphragm, the middle, this little pintle here is connected to this switch right in the middle of it, and like that, and it's gonna make the contact. Now when the vacuum is at 1 inch of water, what's going to happen, the system is going to get sealed, and then we're going to actually create the vacuum in this upper chamber here. So the vacuum is going to be in this side. So this diaphragm is going to pull up, and it's going to keep the switch closed. And that's when our voltage drop down to 0. And so now I cannot recreate it because this chamber is open, but I can show you how this, I'm going to pull some vacuum here. See that? That's how diaphragm works. So so that's actually the kind of diagnostic part of this unit. So that's going to be vacuum created in this, above this diaphragm. Is going to pop up, and it's going to keep the switch closed as long as we keep the vacuum. Now as the vacuum decreases inside the Evap system, now this pressure is going to equalize between the upper chamber and lower chamber, and this diaphragm is going to go down. It's going to open up the switch, and the voltage is going to go back up to 10 to or 5 volts, depends if the car is running or not. And so that's pretty much it. It's very actually simple, but it took me a while to kind of understand and to figure out how all this is supposed to work. So what was the problem here is basically this switch is completely rusted out, and I don't even know how it make any contact at all, because you can see there's a lot of crust in it. But now right in the middle it's a switch, but this switch doesn't even move anymore. I'm just going to break this part. So we can do all the corrosion that's on it, but right in the middle of it, this little switch is, I think it should kind of go in and out to make the contact here, which is completely frozen now. So I don't even know how did it make any signal at all. It got so much moisture, I guess, and it's just completely gone. Let's pop the switch all the way out and see. Yeah, it's just so this is the switch, and this little tab in the middle is supposed to, of course, go in and out to make the contact. That's what the diaphragm is going to actually push on and close the switch, but it's just completely shut. There's nothing left. So again, I'm surprised that this was actually working at all. So this is what it looks like there. So okay, well that's what I want to show you guys, and I honestly still didn't kind of fully understand how until I got this apart, you know. So as we know now, in this part here, this is that second chamber basically that's going to create the vacuum. In this part there's like 1 inch of vacuum, and that switch, the diaphragm is going to kind of push up against it. It's going to pop up, and it's going to close this switch, and it's going to, you know, drop that voltage down to 0. but and that's going to be the main input. That's the only input the computer uses to figure out, you know, if you have a leak in the system or not. So and that's it, guys. Appreciate you guys watching this video. I hope I learned actually a lot. I finally kind of get hold of this, and that's it. Thank you so much for watching. And as I said, I did not test my vent solenoid. I really should. I missed that. I did not test my cap. But after as I said, after I've seen that input the way it was, I knew that's my main problem anyway. And this car is going to be okay. There's no other problems there. So okay, well, that's it. Thank you so much, and see you next time. Bye bye.